it. I had given you a quiz the last time, and was it problem number 5? Yes, I'm not sure. I think it's 5. So let me do problem 5. I think that was for our quiz before in the previous. Oh, it's number 7. Thank you. That's very nice that you remember that.
Recording in progress.
Otherwise, I would have done not correct exercise. So anyways, let me do problem number 7. So there are 2 equations here that determine our function parametrically. X is given as t plus 1, so they both in terms of the same exact parameter, and t squared plus 3t for y. So this is a pair of equations, and I'm gonna try to find derivative of function. And to do this, I'm gonna need to take a derivative of y and divide by derivative of x with respect to t. So sometimes we will put that t on the bottom to show what is that they're doing. So for the first, for the upper part, numerator, we're going to have 2t plus 3. So power rule for derivatives is here at work. And for denominator, it's number 1. So we end up with 2t plus 3 as a derivative of this function. So that was the answer for the exercise. Now the actual problem says find the first and find also the second derivative. So I can continue with this. So I can find so-called d2y over dx squared. Again, that's not what you were supposed to do for a quiz. And again, my denominator is going to be x prime of t, but for denominator, we're going to have to take the derivative of function y of x. So sometimes we write this like that, and then differentiate it again with respect to t. So sometimes we will say d dt. That's going to look good, but that's what I'm going to do now. So I'm going to take this result and take its derivative, so it's going to be just a 2, so second derivative is 2. And they also say, what about if you're given the value of parameter -1? So you can say at t is equal to -1, we have, looks like same second derivative because it doesn't really use t in it at all, but for the first derivative, I should be a little bit more careful. So dy dx at t equal to -1 is going to be 2 times -1 plus 3. So you just plug it in for your parameter and you get some number, like number 1. So just for practice sake, they ask these procedures. Now, I remember last time I also did an exercise and got a little bit surprised because the derivative came out, the arc length came out to be 0. And I just wanted to say a little explanation of what's going on. I just need to find it. I think cubes, it's like 75, right? 75, that's what I looked at. No, that's surface area, that's not that. It's something else. I remember it was cubes, pair of cubes, maybe before arc length. Yeah, 57. See, not 75, but 57. Interesting, right? Just switch those digits. So we found something, but notice they want to interval 0 to 2 pi. One observation you can make if you don't graph this function is that it deals with a cosine function, which is even, so it's symmetric through the y-axis, right? Even like parabola x squared. And also sine function, which is odd, so it's symmetric through my origin. And turns out the graph looks somehow like that. Symmetric through the origin. And then this piece is symmetric through y-axis and that piece. In other words, it's symmetric everywhere. And that's why all I had to do is just find the value from 0 to pi over 2 and then take it 4 times because there are 4 arc lengths. So you can plug instead of 2 pi in that function pi over 2 and you will get a nice result because I don't remember what the function looked like. I don't want to do the problem again, but the point is you put pi over 2 and you find 1/4 of this arc length and then again and again and again. And of course, question is how you can graph this, right? So there is a calculator I found in the parametric coordinates. It just, I think, one's the first or second calculator, but we needed to play with this a little bit. And the graph that I just put here on the picture is something like that. So there are 4 equal pieces, and that's why you find 1 and then multiply by 4 and you get the whole thing. So the point is that these problems, yes, you do need to make pictures and they are tedious, especially if you go to the second part of the section. But they are doable. You just need to spend a little extra time on them. That's the point. And that's why, in fact, you can see all of them have symbol graphing calculator next to them, right? So they expect you to actually graph this using this special tool, because otherwise not going to get very good results right away. So anyways, that's a parametric set of coordinates using parameter. Usually it's t, so each coordinate behaves a function. Now it's a little different procedure here, because that assumption is related to trigonometry class. If you recently took it, then I'm sure you will remember how you used polar coordinates that are completely different with coordinates that we used to have. So there is a ray with a starting point, and then you can rotate by angle theta, and the distance from that starting point, we call it a 0, will give us the point on the polar plane with coordinates r and theta. These are not x and y, because x and y are totally different. We have 2 axes. You see there's x-axis and there is y-axis. So if we get a point, then there is an x coordinate and y coordinate. But the idea here is completely different. We have distance from the point 0. We can say its origin, but we have a distance and we have angle. And the difference here is that these coordinates, they overlap. For example, if you rotate not by theta, but the other way around, so that's going to be like 360 degrees minus theta. And that's going to be exactly the same point. So r and 360 minus theta And people don't like to put 360, they always use in terms of radians, like 2 pi, right? 2 pi minus theta. And you get exact same point, but it's different description. In fact, you can get even less obvious description. You can go by the angle theta, but if your R is negative, it's going to be totally different point, because R may be positive, but R also may be negative. So if you take the point with coordinates negative R and theta, you can take negative R. So R is not really a distance because it may be negative. So you go by R theta and then you reflect your R. You get different point. How about that? And the idea is there are infinitely many ways to describe points using polar coordinates, and that's what one needs to realize. For example, you can rotate by theta and keep going by another 180, so that angle will be like pi plus theta. And negative R will bring your point back where we had. So if you go pi plus theta, and instead of R, you put negative R, so you're going to reflect it back there. Or you could just keep adding 360, plus 2 times 360, 3 times 360, 4 times 360, or minus 360. So it looks like these coordinates are not as convenient because they are not unique. But they're very convenient when you have graphs that in the circular-like format. And of course, main question is how to convert these coordinates to our favorite X and Y coordinates, and those X and Y coordinates are given as R sine and R cosine. So if you remember how we defined sine and cosines using unit circle, if you take the point on it, maybe I get a bigger picture, it's not very visible. So right now, I think this section completely talks about what you learned in trigonometry. So if you recently took trigonometry class, you're not going to learn anything new. You just refresh your memories. So if you have a unit circle, which means the circle with radius 1 and the center at the origin, then for a point on the unit circle, I can describe using the angle that segment makes with x-axis 2 values. One of them will be a cosine of theta, which is distance here, and the other value will be a sine of theta, which is distance from origin but along y-axis. So in other words, y coordinate of that point. So that's sine of theta. So y coordinate is sine and x coordinate is cosine. Now, radius of this is equal to 1 because it's unit circle. Now, what if radius is not 1? Usually we deal with all kinds of radii. Well, then the triangle is going to be similar because its angles are going to be the same. And since triangles are similar, their sides keep same proportion. So I multiply for that one r by sine of theta. So my sine of theta, right? Why is that? Well, because that's triangle with hypotenuse 1 and the other one is with hypotenuse r. So if this is cosine and that is sine, then I multiply cosine by r and get that coordinate, that length, and sine by r to get the other length. Why is that? Well, because for similar triangles, if you start to divide corresponding sides, like arc sine by sine, you get r, or if you divide r cosine by cosine, you get r, or if you divide r by 1, you also get r. And that's what we say about similar triangles, if they have same exact angles. So that's the key pair of formulas to convert, and those formulas are going to be heavily used in our class. Besides those, there are formulas to convert backwards. But again, backwards, we know there's not unique value, so we should always watch out because the values could be different. For example, if you have a tangent function, it's not just one tangent, there are a whole bunch of tangents. Let's see, why you say whole bunch? Well, because the tangent is here and between negative and positive pi is over 2, but there is another branch of it here, and there's another branch and another branch, and there are infinitely many of them, right? So you should always adjust to the period of the angle you need. That's a little extra, but it's good to be aware of. And also you can see that Pythagorean theorem, r squared is x squared plus y squared is present here. Since it's right triangle, we have the sum of squares of sides is equal to square of hypotenuse. Notice when you have cosine plus sine, so if you're, instead of y, you put r sine, instead of x, if you put r cosine, then you're going to end up with x squared plus y squared, which is x squared is r cosine squared. Of course, r is also squared, plus y squared is squaring r sine, right? Then notice that when you take out r squared, you have a Pythagorean theorem, cosine squared plus sine squared is equal to 1, because of definition of sine and cosine that we just looked at. So that's why I get r squared. And the definition is here, so you got a right triangle and sum of squares of sides equal to square of hypotenuse. And that's the idea. One side is cosine, the other is sine, and the square of hypotenuse is 1. So various ways to justify this. And of course, the first formula is nothing else but definition of tangent. It's opposite over adjacent sides. So if that's angle theta, and this is opposite to it, and this is adjacent, quotient of opposite over adjacent was defined as a tangent of theta, and that's exactly what this formula here says. So these formulas is pretty much all you need to do all problems here, but of course, there is quite a bit of things to watch out. So maybe I can do some exercises, and you can also see how those nice so-called roses could be graphed. And notice in polar coordinates, they will get very nice equations like the one we have here. Because if you try to graph it in XY coordinates, that might be quite tricky, but it is doable. But again, nice and compact equation for such nasty looking curve that is not even a function, right? Please don't mix it up with the parametric coordinates, because parametric, they depend on parameter t, or you can use any letter you like, theta. Here we have different story. Even though if you say the parameter is theta, but it's r, so you don't have x and y coordinates, you have just r, and that's why it's not the same. And it's totally different because this is really pair of coordinates, not x, y, but r and theta. So that's why we can write them in terms of x's and y's, and that's what they're doing here, but I guess I'll do it next time. So anyways, let us refresh how you used to deal with these polar coordinates before. So let me try to, let's say, plot some points, like, for example, 4 exercise. In the polar coordinates, you need to think of point with r theta. R is equal to 0, theta is equal to some angle. Well, if distance to the origin is 0, then you don't really care what the angle is. I shouldn't put y-axis. Should be careful. We have polar coordinates. Right? So the point is going to be here. So r and theta, because r is 0, it's right there. And I say that's not interesting. Well, let's try 3. That says again, r is -4, and theta is -3 pi over 4. Please notice if you know how to read this with r and theta, then it's very straightforward, I guess. So first of all, I'm going to put the angle. 3 pi over 4 with negative sign will be here. Okay. 1 pi over 4, 2 pi, 3 pi over 4. Negative means that we go clockwise. I put another color so better see. So we got also negative r, which means that you don't go 4 steps here. Since it's -4, I have to go the other way. So the point will be here because and r is negative and the angle is negative. Well, you say, Alex, but it's like pi over 4 and 4, so you have totally different description of this point. Yes, because there are infinitely many ways to describe points in the polar coordinates. And that's important to realize. And that's, I think, what gives you plenty of flexibility. So let me try to use formulas to convert these things. I guess these exercises are nice and short, but this section contains quite a bit of knowledge from previous class, from trigonometry, that I believe worth to refresh when you start working with these exercises. So let me try number 23 here. I want to write this with x and y coordinates. So how can we do this? So if they tell you that r is equal to 2 times sine of theta. Well, x coordinate is r cosine and y coordinate is r sine. So if I see just a sine by itself, I definitely want to multiply it by r, and that's standard procedure. So we just multiply by r on both sides of this equation. And then we also going to utilize the fact that x squared plus y squared is equal to r squared. In other words, left side is r squared And the right side will be 2r times sine of theta that I can, using these equations, rewrite with x squared plus y squared for the left side. And instead of r sine, I put y, so it'll be 2y. And you should probably notice that this is something like a circle, right? And indeed, we going to have a circle. So I'm not sure what they want here in this group of exercises. Let me see. Match graph with polar equation. Oh, okay. So it looks like it is a circle, so that's part C here, because we have that type of a graph. When you say, are you sure this is going to be a circle? How do you know? Well, you can either just graph it using polar coordinates, or you could do a little bit of algebra, such as completing squares and get it. So let me complete square. Take half of number with y, which is 1. So if I add and subtract 1, nothing's going to change, but these three terms convert to y minus 1 squared. And then 1 I bring to the other side, and here's x squared. So now you can see that circle with a center 0 for x and 1 for y. And the radius of it is 1 because it's like 1 squared. And you do see that indeed 0, 1 is center of that circle, and the radius is 1. So we do have that graph. How would I graph it without converting to XY coordinates? See, I'm trying to do this problem various ways. So how would you know that this graph is a circle if you did not convert it to XY coordinates? Because some of these functions, you really can't convert that easily. You can do it, but it's not going to be very helpful. So how would I graph r is equal to 2 sine of theta? Well, it turns out there is a standard way to see when r is maximum, when r is minimum, and when r is equal to 0. So for what angles this happens. And r is maximum is going to be when sine is equal to 1. Right? And r is minimum when sine theta is equal to negative 1. And r is equal to 0 when sine theta is equal to 0. Because we have equation where we multiply 2 by 0. So now I need to solve these three equations, and that should help me to graph everything I need. So now I'm in XY coordinates, I'm just trying to find what angles give sine equal to 0, and those be 2 here, because again, sine is y coordinate of the point. So people say that theta is equal to pi times n. So if you take the n equal to 0, you have this point, and you take 180-degree rotation pi, that's this point. Or if you take twice, is this point, and so forth. So you can keep on rotating. So you can technically say it's either 0 or pi or 2 pi or negative pi, etc. Or you could use sine curve to visualize it. Okay, so what is the solution of sine theta equals to 1? Well, that's the point up here. So theta is pi over 2. And again, plus period, which is 2 pi n. because it's not just that point, but it's family of points. You can rotate by 2 pi or vice versa. So n could be any integer. And then similarly for the theta is equal to -1, sine equal to -1, that's going to be negative pi over 2, or people may say 3 pi over 2 plus 2 pi m. So now I'm going to put these points on the plane, and that should produce the graph and actually give me an idea of how the graph is going to look like. So let's do this. So I'm going to start with r equal to 0, and then angle equal to 0. So that'd be my point origin 0, 0. Right. Notice if you rotate by pi, r is again 0. So if you rotate by, like you can see here, pi over 2, and then pi, you get again 0. When you say, how do you know it's pi over 2? Is that 360? Well, notice that if I rotate by pi over 4, so from here I get to some point on the circle, which is going to be 2 sine of pi over 4, so it'll be somewhere. If I rotate by pi over 2, see, it's just, we are starting here. That's why we get to the value. And at pi over 2, by the way, we can see we get a maximum. So radius is 2. So this is point here with angle pi over 2, and radius is 2. And then we return back when we go by angle pi, which is here. Another color. Pi. Then we return back to 0, so we can go back to where we started. And it's not over. We can keep on rotating because now radii become negatives. So actually, instead of going farther here from 0 to -2, since it's -2, we're going to reflect back here. So we actually not going along this because our r is negative, so we reflect them all up here. So we kind of double cover the circle if our angle is in between pi and 2 pi. So we're going over exact same circle twice. And that's not what is shown when you make a graph in XY plane, but it is happening in polar coordinates. So these things are definitely interesting, right? And if I try, for example, exercise like number 24, then definitely the way to convert is not going to work like we had before because it's cosine of 2 theta. So you can rewrite it as cosine squared minus sine squared and then start playing with this. But what I used previously, like I put, remember, r squared is equal to 2 times r sine theta, didn't work because, wouldn't work here because I have angle not theta but 2 theta. And that's why the graphing is totally different, and that's why converting it to XY coordinates is not a good idea. So I guess I'll just try to do this exercise for you right now and recall how we used to graph this polar coordinate type of functions. And that's always the same, minimum, maximum, and zero. So let me maybe grab a little extra piece of board here. So again, my plan is not to make you recall all the trigonometry right now, because we spent quite a bit of time on that. I know that you should have learned this before, but I know that people forget things. So I just want to show you main ideas that you use for graphing, because calculus is all about graphing. So how can I graph this type of a function? And again, I need to see the 0 for r when it happens. And looks like that happens when on the right side cosine of 2 theta is equal to 0. The next is maximum, and maximum will be 1. So it's actually 4 times 1, right? So that happens when cosine of 2 theta is 1. And then minimum is going to be negative. So 4 times negative 1. Okay, so that happens when cosine 2 theta is negative. So in a way, it's kind of similar process to find these solutions. Now it's for a cosine function. So we concerned with x coordinates. Like for the first equation, looks like these 2 points that I can describe as, so now I have 2 theta. Pi over 2 plus pi n. Or you can break this into 2 equations and describe first separately and the second separately. But I think it's nice if you go by pi over 2 and then by pi and then pi and then pi. So you just take halfway and get those. So what about theta? Well, that's pi over 4. I need to divide both sides by 2. So it'll be pi over 4 plus pi over 2 times n. See, these things are not obvious. You really need to carefully write it down. Okay, so when cosine is going to be equal to 1, well, it happens at this point. So my 2 thetas could be described as 2 pi n. And that's why theta is pi n. Divide both sides by 2, right? Okay, so that's for maximum. And finally, let's do theta. When cosine is negative, so that's for this point. Again, cosine is x coordinate. So -1 is here. So we get a 2 thetas that correspond to pi plus 2 pi n. And that's why to get theta, I divide both sides by 2. So this is going to be pi over 2 plus 2 pi n. Actually, plus pi n. And now I need to find the lowest and then get bigger, bigger, and bigger and graph all of those points, and you will see what will come out. So the lowest, when r is equal to 0, that happens when theta is pi over 4. So when angle theta is pi over 4 or 45 degrees, the point is here. Okay, so what happens when we have angle equal to 0? Looks like this happens here, right? When n is 0, so the maximum value is produced. So it's 4. And this makes me see that the graph is gonna go under this curve with equation theta is equal to pi over 4. And we used to take it for granted in the trigonometry class because this is tangent line. And next time I will actually show you the proof why this is going to be tangent, which I think is pretty neat. So we return back to the origin. What happens then? Well, let's see what happens when our angle is pi over 2. What is radius going to be? It looks like pi over 2 is here. So our r is going to be a minimum, which means it's going to be a -4. So when angle is pi over 2, we actually go to -4. So we kind of continue going down here. So instead of being going up, we reflect all of these points because our r is negative. Okay, that's interesting to realize. Okay, so then what? Well, then we'll probably return back to 0 when our angle is going to be what? It's a pi over 4 plus pi over 2. So did I do it right? I had to be a little bit more careful because it's actually first here. So I got a little bit carried away. Well, not really. It's at so goes here and then returns back. So it should be, I think, returning back somehow like that, right? So I think it goes somehow like that, which is interesting, right? So we start to see that when we have the angle that goes from 0 to pi over 2, we produced just this piece. So let me better show it to you. So instead of being here, I had to reflect it there because my r was negative. And then my r will return backwards when our angle goes to pi over 4 plus pi over 2. So when angle gets here, which is going to be 3 pi over 4, it has to return back, but it returns back because it's negative like that. So what happens then? Well, then we gonna go to the angle pi. See, this tedious process, but I hope you went over these ideas when you were in trig class. So it looks like angle theta is pi. We get to be at 4. So it looks like we are going to go here and r is going to be 4. When you say, Alex, r is -4. No, it's 4 from the center, but along the angle pi. And that's why it's here. So now I start to get a feeling what we actually producing. Looks like it's 4 petals rose, right? It looks like that. So it is not that obvious, of course, but I guess that's what it is. So graphing and polar coordinates. Again, my goal is not to overload you with material. I know we already had plenty for today, so I don't think I want to give you a quiz, but just to make sure that you're refreshing your memories, and that's the point. So you can get another one here, like, for example, one, let's see, what is this? What kind of, which one of these equations gives you the line? That could be interesting and exciting to figure out, because this is actually x equals to 2, right? And how could I try to describe this using this equations such as one of the polar ones? Would I be able to do this or not? Well, if you think of x, it's the same as r times cosine of theta, which is equal to 2. And looks like if you have r isolated, you're going to have 2 over cosine of theta, and 1 over cosine is secant. So it's indeed, we'll have that equation. Interesting, right? So anyways, getting used to these manipulations, sometimes they're helpful, sometimes they're not. Sometimes it's better to write the equation using the XY coordinates, such as a line, because if you produce something like that, it'd be quite challenging to graph line. But if you get x equals to 2, well, then it's a vertical line. That's our old favorite. So maybe I will just stop at this stage and have you try to maybe graph another one and see how you can manipulate with various equations. Like, for example, what can I do with 28? Let me do 28 and then I'll let you go, I think. I just love these problems, but again, I don't want to put too much stuff in it. So x is r cosine and y is r sine. So when you see x and y, then right away you replace them with this r cosine and r sine. So it looks like x squared and y squared will be r squared cosine squared minus r squared sine squared, right? So that's our left side of this. And on the right side, it's equal to 9. And that's it. So you have the graph, the equation in polar coordinates. That's what they wanted converted. But of course, sketching the graph is definitely not a good idea in these coordinates, because that'd be pretty crazy. X squared plus y squared minus y squared is equal to 1 is hyperbola. And to write this in the more familiar form, I just need not to have 9. I need to have 1 on the right side, right? So if you divide by 9, you get 1 here, and it's x squared over 3 squared minus y squared over 3 squared. So we know that a and b are both equal to 3, so you go 3 up and down from the origin, because that's your center. So you produce the box, then you get its diagonals. That's how we used to graph in intermediate algebra class. And then when x is positive and y is negative, if you forgot, you can always check the point and see if it belongs to your graph or not. So this point is with coordinates 3 for x and 0 for y. Does it satisfy your equation or not? So if x is 3 and y is 0, you're going to end up with 3 squared over 3 squared minus 0 over 3 squared. Is it equal to 1? The answer is yes. So your hyperbola is going to be on the right side of this box, and those are the asymptotes, and on the left side. Because sometimes it is on the top and the bottom, right? Sometimes it may be here. And that's all you need to graph it. So you definitely don't want to use this polar coordinates to graph something that is like algebraic type of a curve. So again, I think for all of these, it's better to graph using our previous knowledge, except for 36, because that one may be, or maybe you work on it and see what will come out, because that one will probably give you a little bit of a hard time. But again, I think that's good enough for today. I'm not giving you a quiz. We'll have one next time. And so next week will be the last week of class. Next week, we're gonna go over the ideas for the final. So just be around and check the recordings because it looks like semester is getting to an end. So one needs to, I guess, take it seriously, right? And I guess I'm gonna stop at this stage. So have a good night, and we're gonna